Hi, I'm Krista Campbell. Welcome to the second webinar of our Field Operations webinar series, Optimizing Capital Work. Esri's electric, gas, water, and telecom teams are hosting these webinars to share resources and solutions that support field operations. Today's webinar will discuss how field work can be streamlined, providing information to all stakeholders involved in a capital project. We will discuss and demonstrate how ArcGIS supports activities such as field verification of plans, real-time updates, and project status. This webinar is being recorded and will be available to watch again and to share with your colleagues. Please enter your questions in the questions dialog box. You can enter questions anytime during the webinar. We will answer questions at the end as time permits. Questions we do not get to will be answered in a Q&A document that will be shared in GeoNet. Please welcome back Pat Hull, Industry Director for Esri's electric team. Joining Pat and I today are Vincent Fortino, Solution Engineer on the Esri Water team, and JJ Ma, Solution Engineer supporting the utilities and telecom teams. Here's our agenda for today. Pat will discuss the importance of communicating and sharing information when construction begins. He will share how ArcGIS enables staff to provide updates from the field, gain an overall understanding of capital projects, and share this information across the organization, as well as with the public. Vince and JJ are going to show how Esri maps and apps are used to accomplish this. Vince will also share some great customer examples of how capital projects can be shared with the public. Pat, I'll pass to you to get started.
Thank you, Krista, and thank you everybody for joining us today. We are all ready, and we have a lot to show you in 30 minutes. In the last webinar, we looked at ways to organize inspection work and to make it easier in the field. When we wrapped up, we looked at ways to use that information that was coming back in. Bringing information back is necessary for inspection, but it also helps support other work. Today, we're going to look at capital work. Those projects have different concerns. However, there is a significant amount of overlap between the two. For example, most utility workers perform some form of a safety inspection on equipment before they work on it, like sounding a pole to make sure that it's climbable or visually inspecting underground equipment. It's best to use the same tools we looked at last time to capture those inspections and to take credit for those. That reduces the outstanding inspection workload while you're doing normal work. I know utilities that wanted to do this, but the paperwork always seems too difficult. Mobile apps make it easy. And even though we operate different types of systems, this idea applies across energy utilities, water, and telecommunication. For all of us, aging infrastructure is a big problem, and that will drive more capital work for years to come. That, combined with the need to modernize, means that capital work is here to stay. I think this statement on the left captures it nicely. As the volume of capital projects increases, it's critical for utilities to optimize, to standardize, and help automate their project execution process, increasing efficiency. We want to explore that. We want to look at some straightforward tools to help streamline the flow of project information. And it's important that those tools reduce the burden on field employees, reduce paperwork, cut phone calls, and maybe even the number of meetings. Now, many organizations have specific objectives for a digital transformation. They want to use mobile technology to move communication from paper to a real-time digital process. In just the last few months, COVID-19 introduced some rather serious new concerns for physical contact between employees, and contact tracing from passing papers around just makes it that much worse. Last time we looked briefly at this overview of the fieldwork. In all of these concerns, location is at the center. It's the one thing that affects everything that a utility does. And today we're going to focus on understanding what's around the work area. Field workers always perform capital construction work within the context of the existing overall system. We'll see demonstrations communicating about projects in real time capturing status and as-built data in the field, and monitoring progress that can be communicated to everyone. These tools, they build on what we showed in the first webinar, so watch for areas of handy overlap and how they work together to form a complete solution. Now, capital work involves a lot of communication. There is a continual back and forth between field, engineering, project management office, even contractors. They reference preliminary designs and schematics and as-builts. And this diagram represents two things. First, the same information is available to everyone, whether that's a phone, a tablet, a desktop, or on the internet. Everyone is working from the same information. Then secondly, regardless of where they originate, the changes and updates are applied immediately and everybody sees them. New facilities, they have to be tied into the existing network safely and with a minimal impact to customers. And large jobs are placed into service in stages. This represents some challenges for field workers, as well as project managers, and even customers who are affected. So the ability to represent that information and communicate it in real time is critical to managing this capital work. I worked a long time in engineering, and then I also ran field operations for many years. So I have lived both sides of the struggle between work design and field construction. Engineering, you see, designs carefully to their standards, but sometimes the field finds that they could not build it that way, and they feel like they have to redesign the job. We really need better ways to communicate about capital work. So we're going to walk through the capital work process with 3 demonstrations, and they will reference up-to-date information. They will include real-time communications to synchronize information for everyone. And that makes field operations easier by cutting out paperwork and interruptions to find out what's happening on site. One thing that I found helped everyone was a constructability review. Preliminary designs are reviewed by field staff to get input. And we can do this much more easily with convenient apps, just like the ones that we use on our phones every day. Secondly, we want to look at capturing information at the source in the field to track status in real time and as-built details as they are occurring. And then finally, we're going to look at several example agencies that are using project information to communicate with their stakeholders and their customers. Timely reference information comes from understanding what's nearby and clear communication. Think about these 3 questions. How can crews access and use the latest reference maps? How can field staff provide timely feedback to engineering? And how does this project tie into the overall system? A constructability review is conducted by a superintendent before the work is scheduled. It's a connection between field and design. And this is a chance to identify any concerns and get them addressed before the work begins. Vince, can you show us what this looks like in the field?
Absolutely, Pat. As Pat mentioned a few moments ago, last week's webinar ended on a series of analyses to identify candidates for capital improvement. Areas that make it through the process and become true areas for capital improvement, they need to go through design phase and then the constructability review, like Pat mentioned. Here we have an area in our distribution system that has historically been impacted by a majority of the main breaks that our utility organization is experiencing, and we're going through and proposing a new design that's ready for that constructability review. Here is an application called the Proposed Water Design web app that allows those design and engineering teams to communicate their proposed design, how it ties into the existing system, and get it into the hands of the field supervisors that are going out into the field to actually walk that specific geographic location. As I pull up my mobile device in which I access this information through mobile applications like Collector for ArcGIS, similarly accessed like any other mobile application that we use on a day-to-day basis, I can pull up that same information and actually go through and verify that this proposed design is indeed constructible. As I walk through and I come across to the western portion of the design, I notice that on South Eagle Street, there is a string of trees along the east side of the street. And as we see on our map and our latest proposed design, the pipe travels along the eastern side of the street as well. This poses a number of issues for this design, one being the environmental impact that the construction can have on the trees. Maybe they might be historical landmarks, and not to mention the construction problems about digging with root intrusion. So what I want to do is communicate this back with the engineering and design team so that they can make the necessary adjustments with the design right here from the field. So the first thing I'm going to do is drop a red line request. And what that's going to do is allow me to communicate that there is an issue here, and this is where I'm going to communicate what the issue is. I'm going to say that it is critical because trees are a serious problem when it comes to construction. I'm going to add in a description. Trees on east side of street, move pipe to west if possible. And finish that up and put a status of submitted so that they know that it's ready for them to review, and put my name in as the supervisor or the person out in the field that's notating this so that in the case that those teams have more questions, they can come and contact me. Once I submit that, that's now going to be available to them through the ArcGIS platform. I also want to take this time while I'm out in the field to propose a design that is in fact constructible. So I'm actually going to add in more features in GIS, and I'm going to add in an 8-inch main. I'm going to cross the street and then tie it back into the system all the way at the top and allow them to be able to see a design that is in fact constructible. I know that this is the Van Buren Ave project, and I know the project ID is 5212020. And I can submit that, and again, that proposed design is now going to be communicated. As I switch back to my constructability review application, I can quickly refresh and see that these changes have been made from a visual standpoint. Now, I can also utilize widgets such as infographics to actually understand how many redline requests have come in from the field to make those necessary changes. And in fact, to make those changes, I can use the Smart Editor. But once that specific redline request has been changed, we've been able to make the necessary changes from the pipe location. We can come in, utilize that point we dropped as the redline request, and change the status of it to complete. You can come through, change it to complete, save it, and now we've been able to identify and communicate that that has been addressed. Once that's complete, what we want to do is take this polygon that surrounds the design and actually change the construction status to construction ready. What that's going to do is communicate with the rest of my organization and the field construction crew that this pipe is ready to be put in. How do you think this can streamline the communication between the field operations and the engineering and design teams?
Thanks, Vince. Well, the ability to redline those changes is a great way to communicate many forms of information from the field, information that is at its correct location, and to do so without delay. It's so important for field crews to have the latest information and maps right at their fingertips. And every industry has its own procedures, but when work is ready to be connected to the system, it has to be done with the latest information in order to be done safely. Effective project coordination depends on this real-time communication of information from the work site. This is such a huge step forward from a manual process. As we prepare to see this in action, I want to encourage you to think about a couple of these things. How can incremental progress be managed on the project? How can the as-building process be accelerated? And how can we monitor contractor performance better? JJ, you have a very strong background in telecommunications. How can ArcGIS track projects as the work occurs?
Absolutely, Pat. It will be my pleasure to share some insight on this topic. It is extremely important to monitor every single stage within the network deployment process. Imagine the entire team would be able to gather digital as-built, real-time feedbacks, and status updates from the field, and how we can improve the efficiency of remote communications and provide valuable information for the future construction planning activities. So let me just jump in a scene where I am going to be the intern construction manager who just received all the required documents for starting the construction. So right now, I'm just pull out my tablet, and I'm going to proceed to open up my workforce application. In front of me, it's a construction assignment created by a dispatcher from the office. By simply just clicking on it, it brings me directly to the location, along with a lot of useful information, such as like attachment that shows the construction package. Simply, we could update a project right now as saying a start for the project, and then we use the call out to go to our collector app. We could update the project status to construction underway by clicking on the project polygon. Simply go into the editor mode and change the status to construction underway. And then we could submit this edit. And later on, we could further update the status to reflect the end result. How about we just turn off this tracking layer right now and start marking some as-built. The current design shows where to overlash on existing poles and then connecting a new drop cable to the target customer. But the crew actually finds out that the customer just planted a new oak tree, which is in conflict with the original design. So the crew decided on site just to reroute the service drop and need to add a pole to do so. So let's go to our feature list and add a pole. The proposed pole will be a new location. Once we add the pole, we'll be able to put in any additional information, such as pole number, pole type, and height of the pole. And you could also snap a picture. So in this case, I'm just going to use a picture that I snapped. In fact, we could leverage high-accuracy GPS device connecting to our tablet to maintain accurate location information associated to our as-built. The next step will be to attach a multi-port service terminal on the pole. Let's go back to our feature list, scroll down on our equipment list, and add amnesty. As you see, as we move closer to the pole location, snapping is enabled, only dedicated to this equipment. This has to thank to the relationship classes that we set up before we published the layer. Let's go ahead and place additional attributes for this location. Last but not least, let's place an aerial drop to the customer premise from the terminal device via the existing poles and new pole we just placed. Now we go back and screw all the way down to our drop cable. And we go back to our MST location. As you go around the route to the second from the last, you can snap to the latest new pole that we just added on the field, the customer premise. Now we have finished the digitized as-built process. And we would like to highlight some changes we made during our construction by capturing a couple annotations. The first annotations will be focusing on the reroute and the reason why that happened. We could go down here, select a high priority annotations, and going to where the specific location. As we drag around and created a polygon notation, we could identify and state this is a construction related annotation. In this case, I'm going to use a voice command in order to help me typing. Change cable routing due to a new tree. Once it's finished, you can actually attach a picture that we capture on the site. A new tree was planted. Then we just submit our first annotation. And also, the second annotation will be about an observation we had regarding a potential visit is needed in the future, because we found some trees might have encroachment issue in the future. Let's create another polygon, but this time we're going to use a low priority. At this dedicated location, we're going to create the same polygons as we did. Attach a picture. And then we select the type will be a maintenance required. For the notation, we're going to put in a potential visit is needed in the future for tree encroachment issue. Now simply just hit submit. To finish up our field operation updates, let's go back to our workforce application and click on the finish button to complete this assignment. Now let's go back to our desktop. Let's take a look at this war room monitor created with ArcGIS dashboard. Our project manager will receive all the real-time updates regarding an assignment. Simply click on this list for the daily update. You see all the details that we have captured and the latest status of that job. So as you see right here, as I click on this tab, it shows all the updated information showing on the pop-up. But also on the field reporting, we see the 2 notes that we just put in for the potential tree encroachment, and also why we have to do the reroute for that new tree with the picture. And also on the left-hand side, we see a list of pre-configured indicators, a waterfall summary for each stage throughout the process, and now ready for review and shared to other stakeholders. So let me ask you, Pat, what do you think of these workflows? And do you think they will add value to the traditional field operations?
Well, it will certainly add a lot of value. That dashboard view of a capital project is a game changer. In electric, I would want to see locations and summaries of where trench was open, where contractors were working, and what was already in service. There's no substitute for real-time information. And I never liked paperwork, but it has become an even bigger problem as we all think about returning to normal due to COVID-19. Inboxes of daily progress sheets, they're problematic from a health point of view, and that's why tracking projects electronically is so powerful. And like you mentioned, connecting just a simple GPS unit to these apps can add pinpoint detail to the as-built, which is so important in different industries. That is fantastic. Clear project communication stems from understanding the current conditions and where they are occurring. When we have real-time project updating, that information can easily be used to update our customers, internal and external customers, about our plans and our progress. Consider these. How can we keep customers better informed? And when customers have up-to-date information, they won't need to interrupt crews on site. I'd like to see some real examples from utilities around the country, which is what Vince is going to show us. Vince, can you demonstrate how some agencies are communicating with customers about their capital projects?
Sure, Pat. I'd like to highlight that this is one of my favorite aspects of the ArcGIS platform, the ability to communicate internally as well as externally from your organization, specifically to your utility customers. Here we have an internal web application from Little Rock Water Reclamation Authority down in Arkansas. We can notice the distribution system for their sewer system, but we also notice quite a bit of polygons surrounding those pipes. If we zoom in, this is an application that allows those polygons to have attached as-builts to be able to pull them up in reference to the pipe they're surrounding. We click that link, we pop up an image, whether it's an as-built, a tap card, a service request, but ultimately we're pulling up some sort of document that documents what went into the ground and what's actually there. This poses to be immensely useful for all utility employees, whether you're a call center employee, just understanding where projects have gone on, a field employee understanding what's actually in the ground while you're on the field, or even a GIS employee when you just need to be able to reference the as-built documents to to make sure that all the GIS features are as accurate as they could possibly be. But this is just internally. Let's take a look at some of the external applications our customers have. Here at East Bay Municipal Utility District in the Oakland area, they have a Construction in My Neighborhood web application embedded right on their public site. This is used by their customers to be able to identify the active, planned, and completed projects that may be in their neighborhood. Let's take an example to hand. I'm a student at UC Berkeley, and I need to commute into class every day and make sure I'm there on time. I can go into the Berkeley subservice area of East Bay MUD and view whether or not any of the projects that are active are going to impact my commute and make necessary changes. We can take a look at Colorado Springs Utilities, which is a multi-utility organization spanning across electric, gas, water, and wastewater operations. Here they have an embedded application that covers all of their utilities and their respective projects. We can zoom down here towards the Patty Jewett Golf Course, and maybe I'm trying to make my tee time, and I can check the Union Boulevard Platte Avenue project is going to be underway from December 31st, 2020, December 30th, 2021. It's under the design status, so I know maybe next year if I try to make my golf tee time, I can make necessary adjustments for my route to get there. And lastly, let's take a look at Peoples Gas. In the greater Pittsburgh area, I'm commuting from the suburbs into the central portion of Pittsburgh, and I typically take Wilkes Avenue to get to work. Here, through this application, customers can navigate here and go and see where the projects are and what their specific status is. This specific project is in restoration, and it should be done in a matter of weeks. This means that now, as I'm commuting to work, once this project goes to fully restored, I'm able to resume using that route as my commute. This allows customers to have insight as to what's going on from a project standpoint at utilities and not have to bother field employees while they're out performing instructions or have to read road signs while they're trying to drive so that they can focus on the road. Pat, how do you think the utilities can benefit from this type of communication?
Well, thank you, Vince. I really wish that I'd had some of this on my past projects. You mentioned reading signs for large projects. We would always put up a 4x8 sign on the project site describing the project and including general information. And it was often information like work beginning September 2020. It would be so much better to have a website, a QR code, or even an app just for customers to see the actual status and the progress on that project. Well, let's summarize what we've seen. Putting live redlining in the hands of field staff provides an ideal way for them to give feedback on their concerns. Real-time project tracking cuts out the phone calls and paperwork, giving everyone access to the latest status for a project. And many utilities are using real-time information to keep their customers informed about capital work. Location is truly at the heart of field operations, improving the safe and effective delivery of capital work projects. Krista, can you tell us about what's coming up next?
Absolutely, Pat. Webinar number 3 is coming up next, and that's going to take place on Thursday, May 28th. Please join us to learn how ArcGIS enables you to transform fieldwork with advanced technologies. And I hate to say it, but as in the past, these 30-minute webinars go very quickly, and we're not going to have time for questions. And we did get to a few of them in the dialog box, and we will also add questions from today's webinar to the questions document that will be loaded to GeoNet. Thanks for joining today. Stay connected with us on social media to continue the conversation, and we hope to see you next week for our last webinar in this series.